the mysterious universe of black holes. In the vast and mysterious universe, black holes are among the most fascinating astronomical phenomena. Though invisible to conventional light, scientists believe that black holes are widespread across the cosmos, especially at the centers of galaxies. Among them, supermassive black holes play a key role, acting like energy sources powering the motion of entire galaxies. Black holes are regions of space with extremely high matter density and such intense gravitational pull that nothing can escape once past the event horizon. If a massive black hole approached our solar system, its immense gravitational force could disrupt the orbital order of planets, potentially leading to the total collapse of the planetary system we live in. So, how many black holes exist in our own Milky Way? According to estimates, there could be hundreds of millions, mostly of intermediate mass, formed after the death of massive stars. However, the most prominent one is a supermassive black hole at the galaxy's center, around which all stars in the Milky Way, including the Sun, orbit. In the field of space research, scientists often metaphorically refer to central black holes as cosmic engines, due to their crucial role in shaping and sustaining galactic structure and motion. However, this is metaphorical language and not an official term in astronomy. A historic milestone occurred on April 10, 2019, when humanity observed the first ever image of a black hole. This image didn't come from a single telescope, but from the Event Horizon Telescope (EHT) project, a global network of synchronized radio telescopes acting together like one Earth-sized telescope. Researchers targeted a supermassive black hole at the center of the M87 galaxy in the Virgo constellation. This black hole is about 55 million light-years away from Earth and is estimated to have a mass 6.5 billion times that of the Sun. It was the first celestial object observed indirectly using millimeter-wavelength radio interferometry. This breakthrough opened a new era in the study of black holes, mysterious gateways of the cosmos. Following the 2019 success, on May 12, 2022, the Event Horizon Telescope made history again by releasing the first image of a supermassive black hole named Sagittarius A star, located at the center of our own Milky Way galaxy, of which Earth is a part. In the released image, the black hole appeared as a glowing ring, not because the black hole itself emits light, but due to light from surrounding gas and dust being warped by the black hole's immense gravity, creating a unique visual effect. This served as vivid proof of Einstein's general theory of relativity, a century after he proposed the concept of black holes. Sagittarius A star has an estimated mass of about 4 million times that of the Sun, equivalent to around 1.32 trillion Earths. Its event horizon diameter is roughly 25 million kilometers, and it lies approximately 27,000 light-years from Earth. Scientists regard it as one of the most enigmatic and compelling celestial objects in the universe. Although invisible in visible light, this supermassive black hole acts as the gravitational center of the entire Milky Way. All stars, including the Sun, orbit around it. That's why researchers often call Sagittarius A star the heart of our galaxy, as it governs the structure and motion of hundreds of billions of stars. So, how are black holes classified? Scientists categorize them into 3 types based on mass. The first is stellar mass black holes with less than 100 solar masses. The second is intermediate mass black holes ranging from 100 to 1,000 solar masses. Anything over 1,000 times the mass of the Sun is called a supermassive black hole. Generally, a stellar black hole must have at least 3.2 solar masses to form. In September 2022, researchers at the Harvard-Smithsonian Center for Astrophysics discovered a dormant black hole. just 1,600 light-years from Earth. It's the closest black hole ever observed by humanity. Its mass is about 10 times that of the Sun and has been named Gaia BH1. This is a very special system because a star orbits this black hole, making it a so-called binary system, a black hole and a star. So, why hasn't the star been devoured by the black hole's immense gravity? Scientists are still seeking the answer. But how did supermassive black holes like those at the centers of M87 and the Milky Way form? Scientists believe their formation is a highly complex process. The initial theory posits that early stellar mass black holes continuously absorb surrounding matter over an extremely long period, gradually growing into supermassive black holes. In recent years, astronomical studies have revealed a profound link between supermassive black holes and galaxy formation. Most galaxies in the universe formed over 10 billion years ago, and at the centers of most lie a gigantic black hole. These black holes could have formed from the direct collapse of massive gas clouds weighing hundreds of thousands to even millions of solar masses under their own intense gravity. This immense gravitational field shaped the structure and orbital paths of stars in the galaxy. So how many black holes are in the Milky Way? Scientists estimate that for every 1,000 stars, one will end its life as a black hole. Given that the Milky Way contains at least 100 billion stars, that suggests The research team noted that, if confirmed, this would be the first observational evidence of a supermassive black hole ejected from its host galaxy and wandering through interstellar space. So how big can supermassive black holes get? To date, the largest black hole ever discovered is Phoenix A. It is the central black hole of the Phoenix galaxy cluster, about 5.8 billion light-years from Earth. The Event Horizon Telescope data indicates its diameter is around 600 billion kilometers, and its mass is 100 billion times that of the Sun. But how big is that, really? The distance from the Sun to Pluto is about 6 billion kilometers. So Phoenix A's diameter is 100 times that. Even the largest known star, Stephenson 2-18, has a diameter of about 1.5 billion kilometers. Phoenix A is still 393 times larger than that. In essence, black holes are remnants of stars. They end their lives in supernova explosions. At the center of a black hole lies a singularity, a strange point formed when a dead star's mass is compressed into a space of zero volume and infinite density. This singularity generates the black hole's massive gravitational pull from which not even light can escape. By studying black holes, scientists are gradually unlocking the deepest mysteries of the universe. Black holes are key to understanding the true nature of gravity and the laws of physics under extreme conditions. They also offer vital clues about the evolution of the universe and the structure of space-time, as well as the nature of dark matter and dark energy, which together account for most of the mass and energy in the universe, but remain elusive. Today's video on the Science Knowledge channel ends here. Thank you for watching.